Alright, here we go with our second example of a piecewise function. This piecewise function has three pieces to it. This first one is a line because the exponent on x is 1. This second piece is going to look like a parabola, or at least part of a parabola when we graph it, because there's a squared on the x. And this third piece is a constant function, and we'll get into how to graph that in a little bit in case you forgot. Now over here, remember, this is our directions about where to graph each piece. Okay, so I'm going to start first with that and looking along my x-axis just to identify where I'm going to graph. So for the red function, the first piece, I'm going to be graphing between the numbers -4 and -1. So between here and here. So my red function is only going to appear in between those two x values. And I'll notice too that I'll have a closed circle at -4 because this is a less than or equal to symbol, meaning I'm including -4. And I'm going to have an open circle at -1 because I'm not including the number -1 here. Okay, next I'm going to identify where I'm putting my green function. So that's my quadratic. I'm going to be graphing between the numbers -1 and 2. So see, I have this break here between the two pieces of the function. Something's going to happen where I switch over to my green function, and I'm going to be graphing my green function in between -1 and 2. And I'm going to have closed circles for both of those numbers because I'm including both of those, as you can see with the inequality symbols, the less than or equal to symbols. And then my last function is the constant function, and that's for any x greater than 2. So I'm going to be graphing from 2 and on. So kind of out here. That's just a little reminder that I'm going to be going on forever over there. Okay, I'm going to have an open circle when my x is 2 for that function. Alright, now we're ready to begin graphing. And like I said, you can either graph using the y = mx plus b, slope-intercept form tools as you go along, but I'm going to go ahead and make a table because we're not actually going to graph our y-intercept for the red function because that would be over here and that's in the wrong part of the graph. So I'm going to be graphing this function. I'm going to go ahead and write the whole function so that it's easy to see what I'm plugging in. And when you plug numbers in, it's a good idea to plug in your endpoints. So -4 and -1. And I'm going to be plugging in a number in between those just to help me really fill in that line. So how about -2? Okay, I'm plugging these numbers in for x here. So -4 minus 2. That would be a +4 minus 2, which is a +2. Next, I have -2 minus 2, which is a +2 minus 2, which is 0. Plug in -1, I get -1 minus 2, which is a +1 minus 2 is -1. Remember that I had a closed circle when x was -4 and an open circle when x was -1. And of course I'll have a closed circle when x is -2 because that's definitely included in this boundary here. So I always use closed circles if I'm included. Okay, so -4, 2 is 1 point, so I'll put that on. -2, 0 is another point. And then -1, -1, I have an open circle here because I'm not including that number -1. And then I'm graphing the line between those 2 points. Now, I don't go on past -4. I can't put an arrow here because it says here that I'm only between the numbers -4 and -1. So it would be wrong to say I go on infinitely over to the left. So I just stop there. That's where the graph stops. Okay, now we're ready to do our green function, our parabola. Let's see how this is going to look. Okay, we've got negative x squared plus 1. Like I said, let's plug in our endpoints. We've got a negative 1 that we want to plug in and a 2. And then it helps to plug in a number between. So how about 0, because that's an easy number to plug in. Okay, plug them in for x. I have a negative, but then I'm going to square the whole negative 1 as I plug it in for x and add 1. So this negative 1 squared is a positive 1, turns into a negative 1 here, plus 1 equals 0. Okay, at that point I said I was going to have a closed circle. Plug in 0, I'd have negative 0 squared plus 1, which is going to be 1. That's in between the bounds, so I'm going to have a closed circle there. Plug in the number 2. Negative 2 squared, the 2 is the only thing that gets squared, not the negative sign, plus 1. So the 2 squared is a 4. Negative 4 plus 1 is negative 3. Again, closed circle for that point. Okay, let's put those on. So we've got negative 1, comma 0. So I've got a point right here. 0, comma 1. Point right there. And 2, comma negative 3. So point down here. So kind of strange, but remember that this is a parabola. Okay, and my vertex, if we look here at what we know about parabolas, my vertex would have been at 0, comma 1. This is my regular parabola, x squared. I've flipped it with a negative sign, and then I've added 1 to it. So I'm looking something like this. I would go through that point right there. Whoops, I'm having a hard time being steady. Going down here. Now I don't continue on, I don't have an arrow because I have to stop at 2, that's what it says. So I'm only allowed to graph the parabola between here and here. So it's just that little part of the parabola, showing the vertex and a little bit of the curve on each side. Alright, let's do our last one, our purple function, which is just the constant 3. So this one right here is saying that my y is 3 no matter what I pick for x. Okay, so I'm starting at 2, I better plug in that endpoint. I can go anything above 2, so 2, 3, 4, and my y value has to be 3 for all of those. Okay, so let me graph. Oh, and I did have an open circle when x was 2, right? And then I'll have closed circles for the rest because those numbers are actually in the boundaries for what I can be on this part of the function. So 2, comma 3, open circle, and then I continue having a y value of 3 as I go along. Okay, so this graphs like this, and it goes straight across. It ends up being a horizontal line when y equals 3. And that's it. I have graphed my entire piecewise function. Okay, I'm going to go ahead and delete this because this is not part of the graph. Again, these little tick marks, they were just to help me as I went along. So this is what my graph looks like. Okay, I do want to bring it back real quick though to domain and range because this is interesting here. We can see here that I have some definite boundaries for this graph. For my domain, I look at my x's and I don't have anything to the left of negative 4, but I can be any x value greater than or equal to negative 4. So that would be my domain. Notice I stop here, but I continue on forever to the right. So x can be anything bigger than or equal to negative 4. Range is also very interesting because I'm stuck here between negative 3 and 3. I never go above 3 and I never go below negative 3. So my y values are always in between 3 and negative 3. Now I use less than or equal to symbols because I can be at negative 3 for a y value. I can be at 3. I do have an open circle here, but I have points that are at y equals 3 for the rest of this part of the graph. So I can be anywhere in between or equal to negative 3 and positive 3. Okay, so that's pretty much it for piecewise functions. I hope that gives you a good start. Let me know how it goes, and if you have a question about a specific one you're working on or you're stuck, feel free to give me a call or send me a message. But good luck with this, and thanks for watching.